Okay, quadratics here, simultaneous equations and consideration of an inequality for which we're going to be thinking about a graph. Now, this question, if you have a quick look, a quick read, see what you think. Hopefully, in part A, what you're seeing is simultaneous equations here. We've got a line, we've got a curve, they cross. We've got a y equals and a y equals, so that's nice and easy. What we can say is we want to know when the x squared plus x minus 12, y equals that, equals, and we've got y equals 3x plus 3, one equals the other. Quadratic equation here, rearrange and solve. So we've got x squared minus 3x from both sides, minus 3 from both sides, and let's see, we can put this in brackets, nice and easy, x and x. 3 5s are 15, minus 5x plus 3x gives us minus 2x. And so we have x equals minus 3, or indeed x, zeroing the other bracket, x equals 5, both will 0, and give us what we're after. Notice this question, sometimes missed, it's asking for coordinates, so we can't just stop at the x equals. So the coordinates here, we've got to pair these things and say what we're talking about. We've got the coordinates, we've got a minus 3, and we've got a 5 on the x, and the y, go back to either of them. I'm going to go back to this one, slightly quicker and easier than putting in that one. So minus 3, what have we got? Minus 9 plus 3, let's give minus 6, and put 5 in there, 15 plus 3, 18. And so what we have, and this is where our thoughts of a graph will come in, we've got our points of intersection. Now we're considering one bigger than the other. Consider the graphs of these. Now, x squared plus x minus 12. X squared plus x minus 12 is a quadratic. And what we have is we have a line, straight line, 3x plus 3. A straight line crossing that quadratic, and we have found this point and this point. This is now talking about x's alone, so I'm considering here the number line, and I'm considering these points which I found. This one at minus 3, x is minus 3, this one at x equals 5, and I'm after the quadratic being greater than or equal to the line. The quadratic being greater than or equal to the line. Now I would say here, so I'm after this point, that would appear to be where the quadratic is greater, and this point down here. In both those regions the quadratic is greater. In here certainly isn't, the quadratic is less than. So what am I looking for? Well, I'm looking for the two regions. One is x down here, less than or equal to minus 3. And I'm looking for the other region up here, x greater than or equal to 5. Graphs and a quick sketch are often a very good idea when you're solving quadratic inequalities. Usually makes things easy to see. There's my solution, and that is done.